Hey everyone, welcome to day 14 of the Advent of Cyber on TryHackMe. And before we start, please remember to hit the subscribe button down below if you enjoyed this walkthrough. And without wasting any more time, let's just go back to the computer and see what today's task is all about. Alright, so it seems like today we are going to be talking about containers. But before we do anything else, I have a challenge for you. Because on today's task, it will be very easy for you to just follow along with all the steps and get all the answers to the questions. But my challenge is, let us try to learn something new today, and I'm here to help you do exactly that. I want you to learn the key concepts of today's task. We are going to talk about some concepts that can be quite difficult to understand at the abstract level. And if you see here on the top left, TryHackMe is even classifying this room as medium difficulty. Not because the task is difficult or anything like that, but just because there is a lot to digest here. And because containers is probably something that a lot of people haven't really touched upon yet. But if you have experience with containers, I'm pretty sure you're going to love this room. So yeah, let's just get started with the storyline, shall we? It seemed as the sun rose this morning, it had already been decided that today would be another day of chaos in Wareville. At least that's the feeling all the folks at DoorDasher got. DoorDasher is Wareville's local food delivery site. A favorite of the workers in the best festival company, especially on long days when they get home from work and just can't bring themselves to make dinner. We've all been there, I'm sure. Yes, that's true. Well, one Wareville resident was feeling particularly tired this morning and so decided to order breakfast, only to find King Malhair and his bandit bunny battalions had seized control of yet another festive favorite. DoorDasher had been completely rebranded as Hoperu. I hope I'm pronouncing that properly. And all of the Ware's favorite dishes had been changed as well. Reports started flooding into DoorDash's call center. And not just from customers. The Health and Safety Food Org was on the line too, utterly panicked. Apparently, multiple Wareville residents were choking on what turned out to be fragments of Santa's beard. Wareville authorities were left tangled in confusion today as Hopero faced mounting backlash over reports of culinary impersonation. Customers across the region claim to have been served what appears to be authentic strands of Santa's beard in place of traditional noodles. Oh my god, what is happening? A spokesperson for the Health and Safety Food Bureau confirmed that several dinners required gentle untangling. And one incident involved a customer achieving accidental facial hair synchronization. And here we can see there's an unhappy customer with his beard mixed with Santa's beard and also some spaghetti in there, which might also have some part of Santa's beard on the plate. So yeah, I mean, things are not going very well for DoorDasher. Immediately, one of the security engineers managed to log on and make a script that would restore DoorDasher to its original state. But just before he was able to run it, Sir Carrot Bane caught wind of his attempt and locked him out of the system. Oh no. All was lost until the SOC team realized they still had access to the system via their monitoring pod, an uptime checker for the site. Your job? As a SOC team member of DoorDasher, can you escape the container and escalate your privileges so you can finish what your team started and save the site? I'm pretty sure we can help on this, so let's just get started. And as I told you in the beginning, we have a lot to cover, so just brace yourselves and bear with me for a second. You can see here on the learning objectives, just take a look at this. We are going to learn about containers, Docker, images, layers, and container engines. So this is quite heavy stuff, right? And then we are going to explore Docker runtime concepts such as sockets, daemon, APIs, and common container escape privilege escalation vectors. We are going to apply all of these skills to investigate image layers, escape a container, escalate privileges, and restore the DoorDasher service. And last but not least, we are also going to learn that we should not order Santa's beard pasta. Yeah. There's that for you. All right, so let us just set up our lab for today. And again, you're probably already familiar with how to do this, but what we need today is to start our attack box and a VM. Okay, so let's just do that. So again, let's just click on this start attack box. As you know, I prefer using the full screen version of this, so I will just click on this button on the bottom of my screen that says View in Full Screen. It will open a new tab. You can just leave it here, let it load. And while that is loading, you can come back, exit Split Screen View with this minus button here on the bottom of the screen. And now we have full view on the task for today. And you can also click on this green button to start our VM. So that's pretty neat. And for this VM as well, I will click on Exit Split Screen. Cool. Now what's cool about today's task is that we can switch between the target machine and the attack box using these two tabs here on the bottom of the screen when we go into our attack box. So that's pretty cool. Now while that is loading, that will take just a minute or so. So I'm just going to click check on this one. And now I'm going to go into our task for today. And now we're going to start with the fun stuff. So what are containers? Have you ever heard developers saying the famous phrase, well, it works on my machine, right? Well, if we are here oversimplifying everything, I would say that that's probably the reason why containers were invented. And of course, I'm just kidding when I say that, but just think about it for a second. Instead of just shipping code that will behave different on different laptops, different servers, different environments, why don't you just bundle everything that an application needs and you run everything together and you just bundle all of that up, including libraries, dependencies, I mean, everything that an application needs to run on itself without needing any dependencies from the environment. And then you can just pick up that bundle, which we call container, and you can spit it up everywhere and the application will run without any issues. So that would be what the purpose of a container actually is. And of course, you can come here and read all of this, but I want to make it simple and explain it using my own words, right? But then it's also useful for you to understand what is the difference between a container and a VM, because that explanation, it actually sounds very similar to what a VM is. But however, containers are a lightweight solution if you compare them to virtual machines. And why is that? Well, if you take a look at the comparison here, you can see that here on the left, each one of these presents represent a virtual machine. Okay, so we have this one in green, this one in orange-ish, and this one in red. So these are three different virtual machines. And you can see that each one of them have a operating system that is dedicated to that virtual machine, and then there are a lot of the things that you need to run your apps, and then you install the apps inside of the virtual machine, which is great for isolation, but again, it makes things a lot heavier and potentially slow. Now, if you take a look at the right, again, each one of these presents here, represented in, again, green, orange, and red, you will see that these ones are the representation of containers, and they don't need to have a dedicated operating system because that operating system is running on the host. So you can see here that the operating system is here down below on this little box. Then on top of the operating system, we have a container engine, which is what will then manage all of the containers. And then inside of each container, you just have the apps that you want to run and all the dependencies that are needed for that. So that is basically the main distinction here. Think about it like this. From a computing resource consumption perspective, if you're going to spin up a virtual machine, it's like you're trying to rent a house inside of a building. So it requires a lot more resources. You need a kitchen, you need a living room, you need multiple bedrooms. It's like a full house. That is basically being represented here by having a dedicated operating system, libraries, all the apps. So it's one single full unit, right? But if you use the same analogy for the containers, it's just like renting a room because you only need to bundle the app and the dependencies, because here on the container side, the host, the hardware is only running one operating system that supports the container engine and all the containers inside of it. So yeah, that is that. I hope that was clear. That was a lot of yapping, but I just want to make sure that you guys understand that difference. So yeah, let's keep moving forward. Now we have applications at scale. And we also get introduced to this new concept that is microservices. Well, this is basically the way of breaking down applications into smaller pieces where each part can be scaled on its own instead of scaling the whole system. Because before, applications used to be deployed as this big, huge chunk of code, right? But now that we have microservices, we have a way of dividing applications into smaller parts. And if there is the necessity of scaling one of those parts, for example, let me show you. So if a specific part of the application receives high traffic loads, they can scale that part without having to scale the entire application. So that's the core value that a microservice architecture brings. Now, this is where the lightweight nature of containers comes into play, making them incredibly easy to scale to meet increasing demands. Cool. All right. So then we have another key concept that is the container engine. You may have noticed a layer labeled container engine. So let's go here and you will see that right beneath the presents, which are the containers, you see that we have here the container engine layer. So what is this layer all about? This container engine is software that builds, runs, and manages containers by leveraging the host system OS kernel features like namespaces and cgroups. One example of a container engine is Docker, which is what we are going to be covering today as well. Docker is a popular container engine that uses Docker files, simple text scripts defining app environments and dependencies to build, package, and run applications consistently across different systems. Docker is the container engine of choice of DoorDasher. Nice. And so is what we will be interacting with our interactive lab. Awesome. And then we have a short description of Docker right here. So Docker is basically an open source platform for developers to build, deploy, and manage containers. And the rest of the text is basically, again, just explaining what a container is once again, and also mentioning that they are lightweight because they isolate the application and use the host OS kernel. And we already covered this when we discussed the diagram above. So yeah, let's just scroll down. Now we are going to talk a little bit about the type of attack that we are going to be covering today, which is called container escape. And even though containers are meant to isolate applications, they are not as isolated as virtual machines because they share the host's kernel. And if something inside the container gets access to the wrong resource, well, we then have a security vulnerability because we can break out of that container and then get access to stuff that we shouldn't really get access to. And that's exactly what you can read here. A container escape is a technique that enables code running inside a container to obtain write or execute on the host kernel or other containers beyond its isolated environment. So basically escaping. For example, creating a privileged container with access to the public internet from a container with no internet access. Now, for this part here, to make it a little bit more simple, think about it this way. Containers work like a small client and server system on a machine. And when you run commands on the terminal, you're basically talking to a background service called the daemon, which is what we have right here. And this container daemon is actually what creates and manages all the containers. And this container daemon service kind of thing is listening through a special channel called a socket, which are also mentioned right here. And so if someone inside any of the containers can reach this socket, they can basically control the entire container system. And yeah, that would be how an attacker would be able to create a new and more powerful with more permissions or more access, like for example, the one we mentioned before with internet access. So yeah, so now that that is clear, hopefully, I know that was a lot. So yeah, I told you this task for today was going to be a little bit dense, but maybe the practical part of today's challenge will shed some light onto that. So let's just get started with that. The goal for today is to investigate the Docker layers and restore the defaced Hopperoo website to its original service, DoorDasher. And we are going to walk through the steps to beat this challenge together. Again, as I told you, TryHackMe is going to guide us. And so if we replicate all the steps, we should be good to go. So yeah, access points. Now it's time to start using the machine you booted up in task 1. Let's check which services are running with Docker, running the following command. Docker ps. Okay, cool. So let's go to our attack machine right here. All right, cool. And now we can see that we have 2 tabs right here on the bottom of the screen, right? So if we go here and navigate to the right tab, let me click on it. Let's see if it works. Yes, nice. We are now inside of our VM, and now we can run the command that we had there on the task. So Docker ps, and this is our output. Now, can I make this a little bit smaller so it's easier to follow? So let me just make this a little bit smaller. Okay, I will just run that again. And okay, so here on the bottom of my screen, you can see that we have 4 containers, right? So 4 lines. The first one is where the main application is running, so the DoorDasher app. Then we have a where reveal times, which we don't really know what that is. We have an uptime checker, and then we have a container called deployer. Okay, and then we can also see that here on the right side on the ports, that the main application, so the Dasher app, is actually running on port 5001. All right, so let me go back to the task and see what we have next. Again, we can make this bigger once again. So let me put that exactly as it was before. Okay, so we ran that command, which is cool. And we got the same output that we can see here on this image. And again, the main service runs at exactly. So the main application is running on this port. So we can actually copy this and navigate to the web application on our attack machine. So if we go back, let me go into the attack box instead. So on the bottom, on those 2 tabs, just go into the left and then just open your browser right here. We can open Firefox. Boom, there you go. And now just copy and paste the IP address. There we go. Press enter. Boom, there we go. So yeah, this is definitely not the app that we were supposed to be seeing, right? We have Hoparu, and we can search for restaurants, and there's a couple things here, and I can already see some weird stuff. Yeah, there are some some very, very, very angry and unhappy customers. So we can see some bad reviews in here. So yeah, this website was definitely defaced. This is not what we want to see. What we want to see is the DoorDasher app appearing here again. So we have to solve that. Let's see how we can do that. Let me go back to the task. And here it says, let's explore uptime checker. It sounds interesting. So this is one of the containers we found out on our VM. So let's run the following command to access the uptime checker container, which is this command right here, docker exec-it uptime-checker sh. And let me explain you what this command is actually doing. So the docker exec part of it is basically just running a command inside of a container. The -it gives us an interactive shell inside of the uptime checker container, and then the sh just stands for shell. That's pretty much it. So let's just copy this command and paste it on our command line. So we have to go back to the attack box, navigate to the right tab right here, and now let's paste this. Boom, there we go. And now we click enter, and now we are in. So let's see what we need to execute first. Now after logging in, check the socket access by running this specific command. Now, why are we doing this? We are basically trying to reach Docker Engine's communication socket, which is inside of this specific folder and has this name. It's called docker.sock. And this command here, ls, is for listing. Now, the thing is, if inside that specific container, the uptime checker, if we can list the docker.sock that is running on the container engine within Docker by using this command, list, it means that inside this specific container, we have access to resources that are not inside of the container. So we are basically executing a container escape attack. So that's what we are trying to do here. Let's just go and try it out. So just copy the command. There we go. Now go back to the VM and let's just paste it here. Boom. And now press enter. All right. So we have access to the file, which means that the file is accessible from inside this specific container and we can perform the attack. Perfect. Let's go back and see what we have next. The Docker documentation mentions that by default, there is a setting called Enhanced Container Isolation, which blocks containers from mounting the Docker socket to prevent malicious access to the Docker engine. Exactly, but that's not the case here. We are actually able to access it. In some cases, like when running test containers, they need Docker socket access. The socket provides a means to access containers via the API directly. Let's see if we can. Well, we already know that we can. We already tried this. Now, I wonder what happens if we try to run Docker commands inside the container. By running Docker ps, again, to see what processes are running in there, again, we can confirm that we can perform Docker commands and interact with the API. In other words, we can perform a Docker escape attack. Let's see if we can do that. Let's instead try to access the deployer container, which is a privileged container. Okay, that's nice to know, and run the following command. So we are going to execute a Docker command to get an interactive shell, and we are going to go into deployer and get a bash shell. So let's just do that. Copy the command, go back to your VM, and now just paste it here. Boom, press enter, and we are in. Basically, we were able to access a privileged container while we were still inside of the uptime checker container. So we were able to execute the container escape attack. Now, this is a privileged container, so I'm pretty sure there's a lot of juicy stuff inside here. Let me go back to the task and see what we have next. Type who am I and check which user we are currently logged in as and explore the container and find the flag. All right, so first, who am I? This is a command to understand which user I am at the moment. And apparently I am the deployer. So I'm basically owner of this container. That's cool. So let me see what we have inside of this particular folder where we are, which is called app. So if I just type ls to list all the files, there is nothing here. So what I will do is I will type cd for changing directory and type 2 dots like this. Boom, and just press enter. What this will do is we are going to backtrack to the previous folder. So press enter, Now we are on the main folder pretty much, and we are going to type ls once again to list all the files. And wow, there's a lot of stuff in here, and I already spotted the flag right there. There's a flag.txt right there for us, and let me see if there is anything else we need to do. Okay, and as you can see here, it seems like we made it. We managed to make it to the container where the script to restore the site to its former version is. Save the day and run the recovery script in the root directory to recover the app using sudo. Alright, so let's run this script. I didn't even notice the script code. Oh yeah, the script is right here as well. So let's just run this script and recover our website. I'm going to type in sudo, which basically means that you're temporarily using administrator privileges to run something. And we can do that because we are the user deployer, as we've seen before. So I'm going to run the specific script. So just put a / and recovery underscore script.sh. Just press enter. This is going to execute, and hopefully we are going to be able to save the DoorDasher website. And I can see here on the bottom left of my screen that the hackers have been defeated and that the DoorDasher website has been restored. Awesome. But don't forget, we still have the flag here. So let me just cat this flag. Cat is a Linux command that we can use to read text files. So flag.txt. There we go. Press enter, and there we go. We have our flag. I'm just going to leave it here because I'm pretty sure this is the answer to one of our questions. Now, if we go back with that run, you can see for yourself by refreshing the website, and as a reward, you should be able to find the flag in the same directory as the script. Yes, we already got the flag using the cat command. Exactly, we already did that. So that's great. Now, we have a couple questions. We have the answer for one of them, which is this flag. Let me see what the first question is all about. What exact command lists running Docker containers? Oh, we already know this. This is Docker PS. Perfect. Now, the second question is, what file is used to define the instructions for building a Docker image? Now, do you remember this? This was something we actually touched upon during the theoretical part of today's test. So let me just scroll a little bit up. So this was around here. There we go. As you can see here, Docker uses Docker files as simple text scripts defining app environments and dependencies to build, package, and run applications consistently across different systems. So the answer is Docker files. Let me scroll back down, paste this, and there we go. We got the right answer. Now the flag, we just have to copy this from our VM. Let me just go back and copy that. Let me go back and paste it right here. Boom, enter, and there we go. Now we have a bonus question, and you know these bonus questions are always good, right? So there is a secret code contained within the new site running on port 5002. This code also happens to be the password for the deployer user. They should definitely change their password. Can you find it? Okay, this is interesting because I remember something with the port 5002. If I go back here and I just exit this and I just run Docker PS, I remember something about 5002 right here. Exactly, Wareville Times. Apparently, this is a different website. So let's just go to the main, sorry, not here, here, the main attack box where we have our browser. And now here, I actually forgot to see if the website was restored. Yes, it was. So just make sure you refresh this page on port 5001 to see if your DoorDasher website is back and you actually have what you're supposed to have within the legit website and not the other hooperoo kind of thing. But now for the bonus task, make sure to navigate to the right port. So 5002, same IP address. Okay, and yes, Wareville Times. Exactly. This is what we found when we ran the command docker ps right here. Can you see it? So this was the second container that we had, Wareville Times on port 5002 once again, just to make sure that was clear. So moving back to our browser on the attack box, I'm going to make this a little bit smaller so we can see what is happening. And okay, let's try to keep things a little bit easy and simple before we dive into any inspection, trying to intercept any requests or see if there is any like comments on the source code. Well, I find it that it's quite interesting that these three words in bold, in red, in this text, this reminds me of like steganography. Are they trying to hide it on plain sight? Like deploy master 2025 exclamation mark. Let us try that. So deploy master 2025 exclamation mark. Boom. There we go. It was that easy. So yeah. And then last but not least, we have plenty more where this came from. So if you enjoyed this container security side of things, trust me, there is a lot more to cover. We touched upon on a lot of key concepts and a lot of key ideas, but if you want to dive deeper, make sure you check this container vulnerabilities room. And yeah, don't forget to click check on the last question. And there we go. That was a lot of fun. And that was it for today. I really hope you enjoyed today's walkthrough. If you did, please remember to hit that subscribe button, leave a comment below, and I'll see you in the next one. Bye!